This is the next math video for your week, as the last one you should have watched was about area. We're going to be learning about another way of looking at area with specific types of measurement. So in your math textbook, you should be on page, I'm just seeing where it is, 353. Yep, 353 is what page you should be on. Okay, so 19.2, we're going to look at how to find the area of a shape. You might remember that in the last video, we talked about counting square tiles to figure out what the area of a shape is, which means how much surface area is there, what is inside of the shape, basically. So in this case, we would count up 4 tiles and say 4 square units. Now, what you'll be looking at mainly with math moving forward when you're trying to find area is that it will say, the polygon will say if you're measuring in centimeters, inches, feet, etc. So in this lesson today, we're going to be looking at polygons that are measured in centimeters squared or inches squared. The reason there's a little 2 up here is because it's saying it's 1 square centimeter. This is 1 square centimeter. A square that should be perfectly all sides the same length. We have 1 centimeter on all sides, so we call that a square centimeter, but we shorten it with just that little 2 next to cm, which is our abbreviation for centimeter. Okay, so the square centimeter, or cm squared is what we would say, is a metric unit of measure for area. So a 2 centimeter square is made up of 4 1 centimeter squares. Its area is 4 square centimeters. So each one of these boxes is 1 square centimeter. The whole box together, or square, is 4 centimeters squared. A 3 centimeter square, meaning it is 3 centimeters long here and 3 centimeters long here, is made up of 9 1 centimeter squares. We can see that it's 9 centimeters squared by counting each of the tiles, or multiplying, which is what we'll transition into mainly doing. When you multiply 3 on one side times 3 on the other side, you would get an answer of 9. That tells you that is the amount of squares inside this square. So it is 9 centimeters squared. Let's put that into practice here. So each of these square units is 1 centimeter squared. We are going to count how many squares there are across and then how many there are down. I'll circle the group that we're looking at. So we have here 1, 2, 3, 4, 5 square units across. Okay? So we're looking at that and then multiplying it by how many there are down. 1, 2, 3, 4, plus 5 up here. So 5 times 5 equals 25. That is how many squares there are all together in this shape. We do not need to count them up because multiplying is going to be our faster option. So if we multiply how many there are this way times this way, we would get the answer. It says a 5 centimeter square is made up of how many 1 centimeter squares? 25. The area of each 1 centimeter square is, that means 1 little square here. What is the area of it? 1 centimeter squared, or 1 square centimeter, which means it is 1 centimeter on every side. That's all it means when it says it's 1 centimeter squared. So the area of the 5 centimeter square is 25 square centimeters. Okay, so there's 25 squares. Each one is 1 square centimeter, so the area is 25 square centimeters. Let's put that into practice here. It says to find the area of this figure, we're going to have some half square tiles, which we looked at in our last lesson as well. When you have half square tiles, 2 equal 1 whole. So let's count up how many full square tiles there are. 1, 2, 3, 4, 5. Plus 2 halves that equal 1 whole. So we've got 5 plus 1 equal 6 centimeters squared, and we're going to be measuring in centimeters squared because we can see that right there. So 6 centimeters squared is the area of the figure. Okay. This is also going to be some graph paper that measures in centimeters squared. We can see that here. So since this is 1 centimeter across, we know all of these are also 1 centimeter across or down. Okay, let's find the area of this one. 1, 2, 3 times 1, 2 equals 6 centimeters squared. Yeah, I don't think with my Chromebook I'm able to do the squared part, but we'll say square centimeters and cm for centimeters. Okay, 1, 2, 3, 4 plus half and a half equal 1 whole. So it's 4 plus 1 equals 5 square centimeters. Okay, we're just counting them up as we used to do in the last lesson, but now we're only measuring in square centimeters. 1, 2 plus 1, since the 2 halves equal 1 whole, is 3 square centimeters. Okay, let's try this one. 1, 2, 3, 4, 5 plus another 1 equals 6 square centimeters. Okay, what about this one? 1, 2, 3, 4, 5 plus this altogether equals 1 whole. 2 halves equal 1 whole. So 5 plus 1 is 6 square centimeters. And finally, 1, 2, 3, 4, 5 plus 1 is 6, plus another 1 is 7 square centimeters. Okay. Remember, every time that 2 halves make 1 whole, and you could sort of separate them, drawing a circle around them, combining those two for you to more easily see that's 1 whole. Okay, so which figure has the smallest area of the ones up here? Okay, we had 6, 5, 3, 6, 6, and 7. The smallest area is figure C with 3 square centimeters. Figure C. Which one has the largest area? Can you see? Figure F has an area of 7 square centimeters. That's the largest. Okay, and the rest of them have the same area. Or sorry, not the rest of them. 5 square centimeters we didn't end up using, but A, D, and E all have 6 square centimeters as their area. Okay. Now, another way that you'll see that we would commonly use for area is measuring in inches squared. Okay, we were looking at shapes that measured in 1 centimeter across. Now we're going to look at tiles that are 1 inch across. 1 inch this way, 1 inch this way. We call it 1 inch squared. Over here, it shows how we would normally write it. We would write it IN period. That's our abbreviation for inch. And then a little 2 means squared. So that is the way that we would usually write what the area is if we're measuring in inches. Okay, so a 2-inch square is what you'll see here, meaning it's 2 inches across here, 2 inches across here, is 4 square inches. It's 4 square inches because it's 2 times 2, or we count up 1, 2, 3, 4 inches altogether. So this one is a 3-inch square, meaning it's 3 inches across this way, 3 inches across this way. To find the area, we multiply or count up the tiles. 1, 2, 3, 4, 5, 6, 7, 8, 9, or 3 times 3 equals 9. A 3-inch square is made up of 9 1-inch squares. We would call the area 9 square inches. Okay, here is another figure. It is a square, and it says it's a 5-inch square. So without even counting, we know it's going to be 1, 2, 3, 4, 5 going down, and 5 across. What is 5 times 5? 25. So a 5-inch square is made up of 25 1-inch squares. The area of each 1-inch square is 1 inch. 1 inch squared is how much is inside of this. So the area of the 5 inch square, this whole thing, is 25 square inches. If we count them up, we would get that answer or multiply. Here is a figure with some half squares. Remember that 2 halves equal 1 whole. We've been doing this in the last 2 sessions, so you should be able to remember that. Now find the area of this figure. If we count them up, we would figure out how many squares there are, plus adding in the extra half squares. 1, 2, 3, 4, 5. We have 5 squares. Okay, now we're going to add the 2 halves over here, which equal 1 whole. So 5 plus 1 equals 6 inches squared. Okay, on to the next part. It says, what is the area of each figure? Some of them have half squares, some of them do not. All of them are measured in inches though. Okay, let's figure out how many, what is the area of this figure? We will need to count rather than multiply because it is an unusual shape. 1, 2, 3, 4, 5, 6, 7. The area is 7 inches squared. Let's count up this one. 1, 2, 3, 4, plus these 2 equal 1 whole, and these 2 equal 1 whole. So it's 4 plus 2, which equals 6. And on to this one, we have 1, 2, 3, 4, 5, plus 2 halves that equal 1 whole. So the answer is 5 plus 1 equals 6. Okay. Now, of these ones up here, which one has the smaller area, A or B? Figure B. That would have been hard to tell, which one is smaller just by looking at them. So finding precise area will help you to be more specific with answers to questions like that. Which ones have the same area? B and C. Both have an area of 6 centimeters or inches squared, sorry. And if we want figure A and B to have the same area, what are some ways that we can do that? We want A and B to have the same area. It doesn't mean they have to be congruent. They don't have to look the same, but there needs to be the same amount of square units inside. What could we do? Well, for figure B, we could add an extra square somewhere, like right here. Okay. That would make it an area of 7 inches squared, just like A. Or we could remove an inch squared from figure A. Either one of those would help us to get the same area. Okay, for the hands-on activity, if you have a way to draw out some shapes with some sort of program that you might have on your computer or iPad or phone, then you can draw out some shapes like this with kind of graph paper. That is just optional though. Over here to Let's Practice, let's begin trying to figure out the area of these shapes. With this one, we have centimeters that we're measuring with. This one has centimeters. Make sure you're looking very carefully at what we're measuring with. Down here, it goes on to inches. Okay, try to solve 1 and 2, and then we'll go over the answers. Okay, pause it if you need more time. Okay, what is the answer to number 1? 4 centimeters squared. Can count that up. Next, what about this one? Should be 6 centimeters squared. 5 whole tiles plus 2 halves. Which one has a larger area? A or B? Should say B. And if we want both figures to have the same area, what would we do? We could add 2 tiles to figure A, or we could take away 2 tiles from figure B. Okay, now we are going to find the area of each figure. As you can see here, we have some half